Just a quick background on myself. I've been in the cyber analytics career field for 12 years now, 13 years now. Actually, I used to work with Frank way back in the day. Now we're both kind of teaching some of this stuff. I was in the Air Force for 6 years. And following the Air Force, I started working for some of the defense contractors in the local area. And then now, my current company, Ops Consulting, has developed a curriculum in conjunction with Mike Volk and the rest of the Anne Arundel Community College Cyber Center to bring kind of a hands-on curriculum that teaches you, all the stuff you need to know to be a cyber analyst, okay? So we cover 26 different functional areas. We're not going to cover all of them tonight, just one or two to give you a taste of what we do go through in the class. The idea behind the class, though, is to give you a more hands-on experience. A lot of the classes we found that people were exposed to and gave you a, it was more of a cert prep, right? Prepping you to pass an examination. However, not always did you gain the hands-on experience required to do the day-to-day tasks that were going to be asked of you once you were on the job. So we try and give you some of that experience going into the job so that you can say, all right, I've got my certificates and I've got a little OJT, and now, I can be better functioning analyst for you right away. Speaking of certificates, our class is a 3-level program, okay? So we have Cyber Analyst 1, 2, and 3, okay? When you put them all together, we call it the Growing the Analyst curriculum, okay? And at the end of that, you will get the Growing the Analyst curriculum certificate of completion, right? But throughout the way, you'll also have gained, if you didn't already have these certificates entering into the class, you will get the Network Plus, the Security Plus, and the CEH. Okay, so those are the 3 certificates you can kind of put on your resume and say, hey, I've got the certs, the book knowledge, and the on-the-job functional knowledge. So to kind of piggyback off of Frank's class, for those of you who were here and saw Frank's presentation, we are going to be doing some live demonstrations of Wireshark. I did have a VM set up that, unfortunately, on my home computer didn't mesh properly with the version that we have here. But I'm actually glad that I'm following Frank because he talked about a couple of protocols that we can go ahead and look at live. All right, so the first one Frank talked quite a bit about was his favorite protocol was ARP, right? For those of you who were here, he mentioned ARP. So one thing I did was I performed a live capture. I got a couple of protocols here to show you guys right now, and then I will show you how to do a live capture, and then we'll wrap it up, okay? So the first protocol, like I mentioned, was ARP, okay? I'm going to drag that over to the screen. Okay. Now, ARP, for those of you who don't know or don't remember from what Frank was speaking about, is a broadcast, right? A computer in a network, all these computers within this network that need to speak to each other or speak with the server or speak with the routing device to get out of this network and go to the rest of the internet. They all speak on what's called layer 2 of the OSI model. Frank touched on that earlier, okay? And that's the what we like to call the MAC address layer. All right, computers on that level function and communicate through hard-coded addresses. Oftentimes, they're on the network interface card. Okay, they're 48 bits. All right, the first 6 bytes of that, or 24 bits, will resolve to what's called the organizationally unique identifier, right, or OUI. That'll tell you what type of device, or the manufacturer, I'm sorry, of the device that you're looking at. So it could be Sony, it could be Dell, it could be Cisco, and that can kind of give you a loose generalization of what it is you're looking at, what type of device you're dealing with. If it's a Cisco device, you can assume it's some sort of networking type device. Now you can't really say, well, is it a router, or is it an IDS, or a switch, et cetera, but you can understand the manufacturer at least, right? So the first thing we'll look at here, the nice thing about Wireshark is open source and freely available to anybody. Simply go into your favorite browser and type Wireshark, and it'll pop up. Usually the first couple links are directly to Wireshark's website, and you can download the latest version from there. All right? And that's something that I suggest that everybody does every once in a while, especially if I'm having slow performance on my computer. And this is something you guys can do at home tonight. If your computer's running a little slow, sometimes it's the processor, the computer itself. Every once in a while, you'll find a virus on there that maybe your antivirus software missed. Okay, and you can sometimes identify them using Wireshark by just letting it run for a couple of minutes and see, where are all your packets going, right? What connections have you established? Because one thing Wireshark will do for you is show you the to and from IP address. So if you have your your IP address, which was the source IP address, is 192.168.1.3, for example. That's what the IP address on your laptop is. And you're connecting to some website that you don't recognize. Maybe it's, well, in this case, it's 10.140.19.1. In this case, that's not going to be, some website in another country somewhere. It's a local website that's a private IP address. But let's say it was. Let's say it's something in Russia or something like that. You did an IP lookup online and noticed that the IP address was generating, resolves back to some server in Russia, okay? Or, I don't know, Czechoslovakia, some other country. You're not intending to connect. You went to Yahoo. You didn't want to connect with a Russian site or anything like that, or a Russian IP address. And what you might find is that you've got a virus on your computer that's actually calling back to that site. So I have used Wireshark for that frequently in my home network. And sometimes it's good just to let it run and see what sort of protocols and services are running on your network. That gives you an idea. I mean, you'd be surprised. It's more than just the HTTP, which we'll talk about in a moment, or ARP, like we're talking about right now. But one thing that Wireshark does is it will kind of separate the traffic by layer. So this first layer that I just opened up, it might be a little bit hard to see, but for those of you who have used Wireshark, or those of you who might try and use it tonight or in the near future, there's the standard plus minus symbol next to each level. And so you can expand or collapse. Okay, this first level here, or this first layer, is just layer 1. That's all the bits, all the ones and zeros going across the wire. Okay? I'm going to collapse that so we can take a look more at the Ethernet layer, or layer 2. So this Ethernet layer, layer 2, okay? I see source, and then it says right here del, and then there are what? 6 characters, all are going to be between 0 and F, okay? MAC addresses are always represented in hexadecimal notation. Okay, so they'll always be between each number, each placeholder will be between 0 and F. The nice thing Wireshark does is identifies the OUI for us, okay? So oftentimes we don't have to go look it up on one of the sites that Frank was mentioning earlier. Some of the newer versions, or the newer version of Wireshark will do that for us anyway. But then it'll also give us the full MAC address, okay? And what's happening here is we are trying to, if we look up at the top there, oh yeah, figure out who has IP address 10.140.19.1, okay? What I did was, before I pulled this traffic, I just pinged the default gateway that the machine said was in my network, all right? I flushed the DNS cache so that my computer would have no clue as to who it's communicated with before, and I pinged the default gateway. And in order to do that, if we're on the same network, I have to know what the MAC address is. So that's what ARP is doing for me. It's placing associating the IP address with the MAC address. So the layer 2 address to the layer 3 address, like Frank was talking about earlier. And what this top packet here, 49, is saying is, who has 10.140.19.1? Which physical address can I associate with this logical IP address? All right, so it's going to send a broadcast out to the entire network. That's what all these Fs represent right here, okay? It's sending that broadcast out and it's saying, tell me, I'm 10.140.19.11. All right, and I just did that thing you asked me not to do, which was smack my chest. I'm sorry about that. So when we look at the packet a little deeper, okay, we can see source, and it's a Dell machine, okay? So in this case, we'll assume that it's some sort of, I don't know, computer desktop, because it is. It's my instructor PC right here. And we're sending it out to everybody in the network, okay? So I'm inquiring everybody in the network who has this MAC address, all right? Or what is the MAC address associated with 10.140.19.1? I got to, find or go to the internet, and I need to know that gateway so that I can leave, all right? And that's all we're seeing here, just broken down a little bit more granularly for us. So we have destination. In this case, we don't have a destination yet. It's everybody, so it's just a broadcast. Anybody that can receive this traffic is going to accept it. And the source, I'm the one that generated it. All right, so that was the request. So then this is the reply. Again, we've got all the same characters as we saw before. All right? We've got the response from 10.140.19.1. That's what we were looking for. Okay, and it's saying, hey, my MAC address is 0.1F45FB7D64. Send me some traffic. Okay. Now we can see the second layer of this frame here, okay? And it shows us the manufacturer of this device, okay? Enter a C. Sometimes if we're in a, like your home network, that might be like a Netgear router, right? Or any of the home Linksys, yep. You'll find instead of enter a C, it'll say Linksys. But it'll still have those remaining digits there, okay? Now, in this case, we are sending the traffic to Dell. All right, we're sending it to my instructor PC here. Okay, and the source is from the routing device that we're using in the classroom. All right? And now we look at the protocol itself. Okay, sender MAC, target MAC, sender IP address, target IP address, and pretty much they've just reversed, right? This is the reply in the ARP broadcast. So just by looking at this one layer 2 frame, I can already start mapping out this network a little bit, right? I know the routing device, okay? So that's the device that all of the devices in the network are going to interface with if they need to leave. And I've identified one node, which in this case is the instructor PC. And we know it's a Dell, right? And now we're going to talk about DNS. For those of you who don't know, DNS is what we use to associate a domain name with an IP address, okay? You can see here in Wireshark we have different colors for different packets. So these black ones here that you're seeing on the top and on the bottom, usually that means there might be some sort of issue with the packet itself. Oftentimes it's, probably because it came in out of order, or there might be something wrong with the packet. It's corrupted or malformed, all right? But we're looking at the top one there, the one that I've got highlighted, okay? And in this case, we still have the layer 1 level, right? We've got the layer 2 level, okay? The Ethernet frame. Again, I've got my Dell machine and the routing device with their associated MAC addresses, okay? The IP level, all right, layer 3. All right. We've got the 10.0.5.3. That's the DNS server that's going to service probably not just this room, but most of the rooms on this level. All right. Then we go up more to what we call layer 4. All right. And this is user datagram protocol, or UDP. And if we look at the source port here, okay, 53, we can tell that this is DNS traffic, even though Wireshark labeled it as DNS for us. But if we didn't look there, we could tell, just based off of the knowledge of the TCP/ or UDP ports. And with DNS, actually, it will operate using TCP or UDP, all right? In general, when you're doing a simple query, I need to go to yahoo.com. It'll use UDP, right? But if you're trying to do a complete zone transfer, oftentimes you'll see it that take place over TCP, all right? And then in this case, we have the destination port 55103, all right? That's what's called a random high port that the firewall just selected for me to use, all right? It was available for use, and that's why I was assigned to it. All right, but that was kind of a quick and dirty on Wireshark and looking at some of the protocols. In the class, we go through a lot more in-depth version of this. Okay, usually this class, this portion of the class is probably about 6 to 8 hours, looking at the different protocols, understanding why they're important, what each one does. But we had about 20 minutes, so kind of had to shorten it down.